section that we're going to be covering on Chapter 8. It's actually the second part of 8.6. Today, we're going to focus in on solving rational inequalities, not rational equations. So, jumping right in, we have a rational inequality right here, and there are 3 steps that I would like you to follow. Step 1, solve it as if it were an equation. Step 2, set your denominators equal to 0 and solve. And you're going to have a set of answers. And step 3 is to plot those answers on a number line and test your areas. So go ahead and copy these down. So of course, this is going to be on video. If you need more time copying this down, you could always go back, watch the video, hit pause, and get that going. But anyway, we're going to solve this inequality following those steps. The very first step is to treat it like an equation. So you want to solve this thing, you want to get rid of fractions. Which fraction would you like to get rid of first? Or we could get rid of all fractions at the same time by multiplying everything by the LCD. It's totally up to you. You guys want to get rid of one at a time or all of them at the same time? LCD? Okay, so what would the LCD of 5, 10, and 2 and x be? 10 with an x, right? 10x. If you're confused about multiplying everything by the LCD, then go ahead and get rid of the first fraction by multiplying everything by 5x, and so on and so on. But right now I'm going to try something a little different. Multiply everything by the LCD, 10x, 10x, 10x. Okay, so what happens is you could multiply 10x times 4 and get 40x, and then cancel 40x divided by 5x, right? Which would be 8. Or you could cancel the 10 with the 5 and get a 2, cancel the x with the x, and that's gone. So what you have is 2 times 4, which is the 8 that I just mentioned right now. On the second fraction, the 10's cancel, but the x does not. So what you really have is 1 times x, which is positive 1x. That's what you have left over, positive 1x. Then we have the inequality, and of course the x cancels with the x, and even the 10 cancels with the 2. 10 divided by 2 is 5. And up on top, you still have 3 times 5, which is 15. So we got rid of all 3 fractions at the same time. Just to save a little bit of time, we use the LCD as opposed to getting rid of 1 fraction at a time. But whatever you feel more comfortable with, that's what you should do. So let's now continue to solve. We're going to subtract 8. Subtract 8. We have x is less than 7. That is an answer. And you don't even need the less than. You could have pretended and said that it was an equation, x equals 7, right? So step 2 is to go to the denominators and set each of them equal to 0. So it would be pointless to say 10 equals 0 because we know that that's impossible. 10 does not equal 0. But 5x, if you set that equal to 0, you get an equation that you could solve by simply dividing by 5 and dividing by 5, and you'll get x equals 0. Okay? And if you do the same for this guy over here, 2x, if you set that equal to 0, 2x equals 0, of course you're going to get the same answer, x equals 0. So we have these 3 answers, technically 2 answers. X equals 7, which we know is less than, but you could pretend it's an equal. We have x equals 0. What we're supposed to do is go to a number line and plot those points, the 7 and the 0, and then you got to test answers. This is where it gets a little challenging for some people, but have no fear, the Casio calculator could do most of the work for you, all right? So we need to test a value that's on this side of 0. So in other words, any negative number you want. Which negative number would be good to plug in? Anybody? Because we're at step 3 where we're testing our areas, okay? So give me a negative number. Negative 1 is an excellent choice. It's pretty easy to deal with negative 1. So let's think about this. You're going to take the negative 1, you're going to plug it in wherever there's an x in the denominators. You're going to do the math. And if it's a true statement, then your answers are on this side, right? If it's false, then your answers are not here. Maybe they're over here and over here, or maybe they're just between these two, or maybe they're just over here. So you want to find out where your answers are at. So let's test the value negative 1. When I plug in negative 1 right there, I want to get 4 over negative 5, which is the fraction negative 4/5. Okay, and then I need to add it with 1/10. So let's add it with 1/10. And whatever answer I get there, it should be less than 3 over 2 times -1 because I'm plugging in -1. So that should be less than 3 over negative 2, that's really a negative 1.5. So you could actually write that out, negative 1.5. So the question is, what is negative 4/5 plus 1/10? Of course, we have the skills to do that. We could get a common denominator, or if you have a Casio calculator, you could use the Casio calculator to type in directly negative 4 over 5. I'm doing that right now as I speak, plus 1 over 10. And let me show you what that looks like. So here it is. Again, here's the fraction button. The paint's kind of coming off of it, but if you don't know where it's at, there's a fraction button. And once you get an answer, it says negative 7/10. If you want to convert that to a decimal, all you have to do is hit this SD button, and it'll convert it to a decimal, in this case, negative 0.7. So let me move this to the side. So on this side, I really have a negative 0.7. Negative 0.7. Is that less than negative 1.5? No, that is false. So I'm going to put a line through it that's false. I'm actually going to write the word no right here. I know that this side does not work. Over here are not the answers. So maybe the answers are in here, or maybe over here, right? So let's, or maybe both right here and over here. If that were the case, if both of these were the answers, then I would simply say my answer is x is greater than 0, because everything's on this side. But we need to verify. So let's pick a point between 0 and 7. Anybody? What would be a good value between 0 and 7? 3, okay. 1 would be really easy, don't you think? Yeah? I mean, 3 would be good too. Whatever, let's go with 1, okay? So let's test the value of 1 by plugging it in. A 1 right there will just be a 5, so you have 4/5 plus 1/10. Where could I write this at? Give me a second. Let me, 4/5 plus 1/10. 4/5 plus 1/10. That should be less than 3 over 2 times 1, which is 3 over 2. So on the calculator, 4 over 5 plus 1 over 10. Of course, you could do it on paper by getting a common denominator. 4/5 plus 1/10 is 9/10. So you have 9/10 is less than 3/2, which is 1.5. True or false? 9/10 is less than 1.5. True. 9/10 is 0.9, and that's definitely less than 1.5. So this guy right here is a yes. So I still need to test this area over here. If it's a yes, my answer is x is greater than 0, because you got both over here. Or if it's a no over here, then it's just between 0 and 7, so that'd be a compound inequality between 0 and 7. So any value you want greater than 7, pick one. 8, 9, 10, whatever, right? I want to go with 8. If I plug in the value of 8, let's see if it works. So right here, 5 times 8 is 40. 4 over 40 is 1/10. Okay, 1/10. 4 over 40 is 1/10. And then plus another 1/10. Plus another 1/10. That's really 2/10, which is really 0.2 or 0.2. Question is 0.2 less than 3 over 2 times 8, which is 3 over 16. 3 over 16. So right here, it'd be a good idea to convert those to decimals. So you got 0.2 is less than 3 divided by 16 on a calculator. As a decimal is 0.1875. 0.1875. My goodness, I forgot the decimal. So is that true or false? False. 0.2 is greater than 0.1. So that did not work. That's a no right there. So the only place where your answers actually work are between 0 and 7, this area right here. So that is a compound inequality. So this whole thing, the answer will be the compound inequality 0, 7, x in the middle, less than symbols. That's a compound inequality for that rational inequality problem. Any questions? Moving on. Copy this one down. This one's going to be really fun. So once again, step one is to treat it like an equation, get an answer, right? After that, you're going to go to the denominator, set up each equal to 0, and get an answer. And then you plot those answers, and you test your areas by plugging in values and seeing where your inequality is at. Because after all, the solution to an inequality is an area of answers. It's never just one specific answer, right? Even x is greater than 5 is an area. It's the numbers that are 5, 6, 7, 8, 9, all the ones that are on the right side of 5. Anyway, right here, let's treat it like an equation. What do you want to get rid of first? Which fraction would you like to get rid of first? There's 3 fractions. Which one would you like to get rid of first? The x over 3? Or the x plus 1 over 4? You want to get rid of that one first? Why not? Let's multiply by 4. It's going to cancel. Multiply by 4. Multiply by 4. You multiply everything by the denominator of the fraction that you want to get rid of. You see, on the right side, I'm going to pretend it's an equal sign. You don't have to call it a less sign. I'm going to pretend it's an equal sign. On the right side, all I have is x plus 1 left over, no more fraction. Now, on this fraction, the 4 and the binomial does not cancel out, so I have to multiply 1 times 4, and that will be a 4, and it's still over x minus 2. And then, of course, we still have a minus sign in front of that fraction. And last but not least, you can't cancel the 4 and the 3, so 4 times x is 4x, and it's still over 3. Okay, so we got rid of one fraction. Let's get rid of the other ones. Which one do you want to get rid of next? 4 over x minus 2. So how am I going to get rid of that 4 over x minus 2? By multiplying by x minus 2. And not only that, but everything by x minus 2, right? Yeah, put an equal sign. You could pretend it's an equation, right? Solve it as if it were an equation. Okay. So when you multiply over here by x minus 2, and over here we technically could multiply this whole thing by x minus 2 or multiply each individual one by x minus 2. It's totally up to you. What do you guys want to do? Each one? Yes. Okay. X minus 2, x minus 2. So I'm going to multiply everything by x minus 2. So let's begin with the 1 times x minus 2. That's going to be 1 times x. That'll be a 1x. 1 times negative 2, it's going to be a negative 2. And then we're going to move on to x times x, that's x squared, and x times negative 2, that's a negative 2x. That red x is positive. Then we have the equal sign that we changed the inequality to an equal sign. We're pretending it's an equation. And then on the left side, the x minus 2 and the x minus 2 canceled out. You have a nice, beautiful minus 4 left over. And up here, 4x times x, that's 4x squared. 4x times negative 2 is negative 8x, and it's still over 3. Now, at this point, I could decide to multiply everything by 3, but I'm going to clean it up a bit. I noticed that I could combine the negative 2x with the positive x. What does that become? Negative 1x, right? So I'm going to change this x squared minus 1x minus 2. We have the minus 4. We have the 4x squared minus 8x over 3. Now I'm going to multiply everything by 3. Times 3, times 3, times 3, times 3, times 3. Everything by 3. That cancels out. 4x squared minus 8x minus 12 equals 3x squared minus 3x minus 6. I know. Fun. Okay, so what we need to do now is recognize that it's a quadratic. Let's set it equal to 0. Let's move everything to one side. Now, I'm going to do 3 steps in one. I'm going to subtract the 3x squared. It's going to cancel. What I do to one side, I do to the other. Subtract the 3x squared. That'll leave me with a single x squared. And then, on the same step, I'm going to add 3x, which will cancel. Add 3x. That will leave me a negative 5x. And last but not least, add 6, and that will leave me a negative 6. And that is now set equal to 0, since I moved everything on the right side to the left. And now I have a quadratic trinomial equation, x squared minus 5x minus 6, where the a value is 1. We should be happy about that because whenever your a value is 1 on a quadratic trinomial, you could set this up and think what times what is your c value that if you combine together is your b value. So what times what is negative 6 that if I add together is negative 5? Negative 6 and positive 1. Excellent. That is factored. It is equal to 0. The reason why I wanted it equal to 0 is so I could split it with zero product property and solve. X minus 6, that could be 0. X plus 1, that could be 0. X equals 6 is one answer. X equals negative 1 is another answer. I didn't show my work there, but I hope you guys understand. And that is barely step 1 because I just solved the inequality as if it were an equation. What's step 2 that you guys copied down? To go back and set your denominators equal to 0. It would be pointless to set 3 equal to 0 because 3 is not equal to 0. But x minus 2, you could set that equal to 0. Let me jot this down right here on the side. X minus 2, if I set that equal to 0, I want to get an answer x equals 2. So I want to write down that answer right here, x equals 2. And I have all 3 answers, and I need to put them on a number line and then test the areas of those 3 critical points. So here's my number line. And I have the number 6, I have the number 2, I have the number negative 1, and I need to test areas, right? So let's test the value that's over here on the left side of negative 1. So what value would you like to test that's on the left side of negative 1? Anybody? Negative 2? Okay, yes. Okay, so somebody said that they wanted to plug in negative 2, okay? And again, the calculator could help you, but plugging in negative 2, it's to where your x's are at. Here's my x. I want to plug in a negative 2. That's going to read negative 2/3 on the original. I'm just going to jot that down right here, negative 2/3, okay? And then plug in a negative 2 right there. That'll be a negative 2, take away 2, it's negative 4. 1 over negative 4, that's negative 1/4, but with another negative in the front, that's actually going to be a positive 1/4. So I really have negative 2/3 plus 1/4. I hope you guys were able to follow the math that I just did right there. Did you? Or do you want me to repeat what I just said? Repeat what you just said. Okay. So if I plug in a negative 2 right here, negative 2 take away 2 is negative 4. So you really have 1 over negative 4, which is negative 1/4. But with the negative in front, a negative negative becomes a positive, so plus 1/4. Now this should be less than, that should be less than plugging in a negative 2 right here. Negative 2 plus 1 is negative 1 over 4, so that's a negative 1/4. So it should be less than negative 1/4, okay? So we could do this with the calculator, which I'm about to do right now. I have a calculator in my hand. Negative 2 over 3, I typed it in with the Casio. You could actually type in fractions right there. Plus 1 over 4. I want to hit equal. That gives me a negative 5/12, but I could convert it with the SD button. That's going to be negative 0.416, and it keeps going, but that's good enough. That needs to be less than negative 1/4. If you don't know what negative 1/4 is, simply divide negative 1 by 4 on a calculator, and it'll be negative 0.25. So what do you guys think of that? Is that true or false? This is true. The negative 0.4 is further left, which means that it's less than the negative 0.25. So this is true. So that means that this guy is an answer. That means that all of my answers are over here. So what I'm looking at right now is the inequality x is less than negative 1 as being a part of my answer. But I'm not going to write it yet. I'm just going to say that yes, it worked right there. The negative 2 worked. So the left side of negative 1, yes, that's where my answers are at. But I still need to test this one. If this one works, then I would say from here that way. If this one and this one work, then it would be like x is less than 2. But maybe it doesn't work, right? So let's test it. Give me a value between negative 1 and 2. 1, right? Okay, let's go with 1. Or even 0 would work pretty good, right? So it doesn't matter which one you pick. I'm going to go with 0. If I plug in 0, it's going to be really easy. 0 divided by 3 is what? 0. Okay, and then I plug in a 0 right here. So you really have 1 over negative 2, so that's negative half, but with the negative, that's plus half. So 0 plus half, that's really 1/2 on the left side. I'm just going to jot that down right here. 1/2 on the left side. Question is that less than, plugging in 0 right here, that'd be a 1/4. Is that less than 1/4? That's the question. Is 1/2 less than 1/4? No. Okay, right? If you think about something in the real world, like your tank of gas, right now the gas is so expensive, half a tank is not less than 1/4 of a tank, right? So that did not work. This is a no. The 0 did not work. That means that no number in between -1 and 2 is going to work. Okay? So let's test over here. Let's pick a value between 2 and 6. Anybody give me a number between 2 and 6? 5? Okay. 4? Yeah, I mean you could use anything, right? I'm just, you know what I'm looking at up here, what number would be nice to have right here on this X? 3 would be nice, huh? Because 3 take away 2 is a 1, and I'd end up with no fraction. So, I mean, you could always think about what you're going to do before doing it to see what is easiest for you. So if I do plug in a 3, for example, plug in a 3 right there, what's 3 over 3? 1, all right? And then plug in a 3 right here, that's 3 take away 2, that's 1. 1 over 1 is 1, so you have 1 take away 1, 0. Which is 0. You see, by picking the 3, I was able to do all this in my head. Again, 3 right here, 3 over 3 is 1, 3 take away 2 is 1, 1 over 1 is 1, you have 1 take away 1, that's 0. Now plug in a 3 over here, 3 plus 1 is 4, 4 over 4 is 1, so 0 is less than 1. It is. So this one does work. This is a yes. Last thing to check would be on this side over here. Give me any number you want that's on the right side of 6. 5 is not on the right side of 6, that's on the left side. 8, okay, 8. Any number? Yeah, whatever. We'll use 8, sure. So let's check 8. So let's plug in 8 right here, 8/3 on a calculator, 8 divided by 3. That'll give me the decimal 2.6. 2.6, it actually continues. And then we have minus, we have this minus sign. There it is, minus 1 over 8, take away 2, that's 1 over 6. So minus 1 over 6, 1 divided by 6, that's the decimal 1.6, that continues. 0.16, I'm sorry, that continues. And that should be less than, when I plug in an 8, I guess 8 didn't work out that great. When I plug in an 8, 8 plus 1 is 9, 9 divided by 4, 9 divided by 4 is the fraction 9/4, which turns to 2.25. 2.25. All right, so if I take away do 2.6, take away 0.16. 2.66, take away 0.16. That gives us 5/2, which is 2.5. Question is 2.5 less than 2.25? And the answer is no. So this is a no. So the only place where your answers are at are between 2 and 6, and also on the left side of -1. So with that said, with all of that work, it's beautiful, isn't it? We're going to write our answer. Our final answer is going to be the inequality x is less than -1. And then you're going to put the word or, and then you're going to put the compound inequality 2, 6, x in the middle, less than symbols. So this entire thing is your answer. X is less than -1, or x is between 2 and 6 as a compound inequality. It doesn't get crazier than that. If you were able to follow along right there, that's fantastic, and the homework should be easy. Again, the homework is the same worksheet that we started yesterday. If you take a look at it, there's only a handful of questions that were inequalities. I'm talking only 4. It was numbers 10, 11, 12, and 13. And these are all way easier than the one we just did, okay? But once again, solve it like if it were a regular equation. In this case, multiply everything by y to get rid of the fractions. Get an answer, plot it on a number line, go back to your denominator, set those equal to 0, y is going to equal 0, plot that answer, and then test your areas, and you should be able to determine whether you have regular inequalities, compound inequalities, or maybe even both. Okay? So for the rest of the class, please work on 10, 11, 12, and 13, and please ask me for help if you need it.